Hey folks, welcome to the Energy Sketch. Michael Johnson here, 12:12 p.m. Eastern Standard, whatever, Eastern Time on Monday. It's the 17th of February. We're going to talk today about heat. This is a bit of a rant today. We're going to talk about decarbonized heat. I've got three photos here that I've took recently around town, around Montreal, and we're going to dive into them. And I'm going to share some innovations from two different startup companies that are coming out of the Alternative Fuels Laboratory at McGill University, FEX Energy and Altiro Energy. As they deliver beautiful, elegant, nice solutions for decarbonized heat. But first, we got to get our whatever little coffee here. And well, we got to just get into the flow. And of course, we got to say our disclaimer, right? I work in energy. All opinions are my own. We're riffing here. Everything is a sketch. It's an order of magnitude. Although I strive for accuracy and precision and good information here, a lot of this is stream of consciousness, riffing off the top of my head. So no guarantees, no refunds. Don't use any of these calculations for anything critical. Uh, check the numbers later. But again, we're just riffing, we're sketching on the whiteboard because I enjoy sketching on the whiteboard, and I believe that it's important often to zoom out and just sketch things at the simplest level, the simplest order of magnitude that we can to really get a feel for things, how things relate, and how things scale. But again, we strive for accuracy, we strive for good information here, but there's no guarantees and no refunds. This is a riff, stream of consciousness, a stream, and welcome. Yeah, let's get into it. So check it out. Look, on the left here, this was, whoa, that's not what we want to do. We wanted to do this. This thing here, this was at a Christmas market that was set up. And these are typical in, I love the Christmas markets around Berlin or Germany. Little public squares where they'd have little booths set up, and you would go, you'd get your hot wine, you'd walk around, you'd get good food, entertainment, live music, um, shops, people selling stuff, like just good times in the city, urban Christmas. And they had a kind of a Christmas market like that set up at the Atwater Market here in Montreal, and I was going for a walk down by the canal and spotted it. And so I walked up to this. It looked inviting. Well, in retrospect, it wasn't that inviting, but we'll get into that in a moment. There was an open air fire here, burning some hopefully local biomass with all the nice. Oh my God! Now this thing. Oh, sorry, technical difficulties here. Um, Okay, no, we're just going to use the mouse today. Uh, okay, going to unplug this and plug it back in. On the left there is a picture of this. Well, it's a trash can. It's an open air fire burning from a trash can. And I was freezing cold, and I happened upon this thing and thought, oh, how lovely. I can put my hands on these metal bars thinking that they were going to be heated, right? My hands are freezing cold. It was a cold day. I was like, oh, great. I can like get some heat here. No, they're not heated. They're cold. They're metal. They're only to prevent people from getting too close to the fire, right? So I thought fail, like design fail number one was that there's cold metal. You want to lean against this thing, you want to hold on to it. Wouldn't it be lovely if instead of just wasting that heat out into the atmosphere, we actually had some kind of a system to capture some of that heat and put it into those nice rings around it, or have some heated seats nearby where your ass could get warm from the fire, because this is often the issue, right? Fires heat by radiation, but they cool the rest of the building. If you have a fire in your home, it's heating that room that it's in by radiating the heat from the burning stuff, but it's unfortunately sucking in cold air essentially from all the leaks of all the other rooms around your house, and so it's cooling the rest of the house. That's a bit of a rant, but we'll come back to this topic here. I hate fires. There's something romantic about the fire, and yes, I agree. If your fireplace is to code, let's say, and that means like high efficiency, it reburns the smoke and it doesn't emit smoke. And maybe you're on a piece of land and you've got your own, forest that you tend, and, branches fall and you collect those and you burn those. Like, okay, in some cases, like that can be fine, but like these like public open air fires for, right, for these kids here to, now my thing's not working. Well, anyway, for kids to roast their marshmallows here, right? That was the purpose of this thing, was to roast marshmallows. So that was kind of not that nice. Like, you stink afterwards. I was sitting next to this fire for like 5 minutes, maybe 4 minutes, talked to some people around. Actually, I got excited. I'm like, hey, yo, I got a solution to decarbonize this freaking this nasty smoke here. Right? It's not that pleasant. It's smoke and you stink, and the cookingness of it is really not that nice anyways. And it was a huge trash can essentially with an open fire in the middle, so kids couldn't come with their marshmallows either. So it was a kind of a big fail in my mind, on all those levels. And I'll get into a proposed solution using iron as a fuel a bit later. But for right now, we have some technical difficulties. We're going to have to. So I lost connection to my Wacom tablet, which is like the most essential piece of this whole sketching business. And now we got it back. So we're back. Um, okay, rant number 2 was here, down at the Lachine Canal, the lovely Lachine Canal in Montreal. There was a construction site in the deep of winter. I mean, this was a little while ago. It was cold. It was probably minus 20 Celsius. There's a construction site here. You can see all these graffitis here on the wall. This is underneath a kind of it's an underpass where the Lachine Canal goes under. Lachine Canal is here. There's some people skiing. There's people biking here, running. It's a lovely spot, all times of the year. But these are diesel burners, essentially. Diesel, we're burning diesel. There's a fuel tank under here. There's 3 of them, 1, 2, 3 of these things, burning diesel in a flame inside here with a heat exchanger. Here's the exhaust. All the exhaust is going out here, and the heat is going through these flexible tubes into the back of this construction site. And I thought to myself, well, I mean, it's a challenging setup because it's like remote. I mean, we were talking yesterday about metal fuels and using them, the aluminum concept, and using it as a remote energy carrier. You want to deliver something remotely. This is essentially a remote use case, right? It's off grid. It's a construction site. There's no plug. There's no like high voltage, high current, 220 volt, plug that you could just plug into and provide, a heat pump and nice low carbon electrical created heat here. So it is a challenge. And we choose to solve that challenge using the magical liquid hydrocarbons. So there's diesel tank under here. And I kind of spied here. Of course, I love seeing these temporary fuel installations. So I kind of spied through here. You could see there was a little hole, a kind of an inspection hole in here, and you could see the burner. You could see it was glowing red hot. This thing was burning. It does need electricity, though. I checked on the side here on the electrical requirements here, because it's got fuel pumps and control systems. It's measuring temperature, stuff like that. So somewhere it's connected to electricity, but only to manage the sensors and the auxiliary equipment. We would call that the auxiliary stuff. And again, we'll get into a little bit of a discussion on how we could use instead iron as a decarbonized fuel alternative for this type of remote customer, particularly in a place like Quebec, where we have abundant. Well, I mean, they say that it's getting less and less abundant as industries are scaling up and they're grabbing up all of the remaining power blocks that are available. But I mean, Hydro-Quebec has a plan to grow significantly our energy production via things like wind and solar. A few projects announced lately on the wind front. Now, on the right here, this is a bit of a rant. Have you ever walked into one of these grocery stores right? We're going to get into this right now. We're going to rant about this. This, pardon me. This is a rant, people. Hashtag rant. So this is the door to a hospital. I was going for a walk and near the Mount Royal, and there's a hospital there. So I just stopped in, got a drink of water, and walked out through the door here. So this is one of those doors that opens this way, opens this way. But there's another one of them further upstream. There's another door, and there's another door. So there's like triple sealed doors here to manage the temperature because it's bloody cold outside and you want to manage the people want to come in. You've got these automated doors, but the issue was like the heat was right here at the first door. So immediately when you open this door, the heat escapes out there, and there's another blower here, and that heat goes directly outside. So like this is just like a little thing about, and you see this in the grocery stores also that intermediate sort of not mezzanine, but sort of that intermediate zone between the cold and the hot often is heated directly with these things. I mean, there's some radiant heaters here. There's often like hot air blowing out of these things. That's to me like that's not the right place to be heating. Like I get it, you want to maybe have a curtain of air that's coming down to kind of prevent hot air from going out and prevent cold air from going in. But what you're doing here, you're just like when you open these doors, the hot air is immediately going out and you feel it. Like you open the door, oh, boom, it's like hot. So you've got really hot next to really cold, which is just bad for efficiency. So let's jump into this one a little bit here. Again, this this is a rant, and we're going to make it in a red color here. Um, so this is the door. Let's call this behind door number one, right? And let's sketch like a top view of this room. Let's say here's the cold outside. Outside is here. La 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 la. Cold, and there's a wall here, and there's a sliding door here. This is door number one. There's another door here. Sliding door number two. And let's just leave it at that. This is hot inside. I mean, what is the function really of right? This door slides back and forth. This door also slides back and forth to let you in. And the best way to do this, if you're conscious about these things, and you see this in restaurants too, also, in Montreal, often older buildings, they'll sort of like have a bit of an ad hoc thing. Maybe this is a curtain here, and this is the front door. So ideally, what you want to do is, here we are. We want to come inside the room. Da, 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 da. The doors open. Da, 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 da. We come in here. Just hang out here. Wait here. Wait for these doors to close, and then continue on into the uh, room here because ah, uh, eraser's not working. The issue is that if you right, what we're seeing when I show this picture over here on the left, this is the problem that we're putting right here. Right here, we're putting massive heaters, essentially. Massive heaters. This is the wrong way to do it. In my mind, again, I'm not a building engineer. I just think about thermodynamically, this is waste, right? We're putting the very high temperature next to the very low temperature, which just essentially, when these doors open, all the heat essentially escapes. So really, this area should be a buffer zone. It should be, generally speaking, like unheated. Maybe some passive heating. Like let's bring back, heated floors, more passive heating rather than just things like these patio lanterns that are just so ineffective, so inefficient, and we're just wasting all that heat out to the atmosphere. Um, there we go. That's our rant to start the episode. Now let's get into a little bit more into the more technical, maybe more interesting parts here. So we were talking about this thing, right? This thing. Wouldn't it be nice if this was hot. This would be so nice if this tube could be hot and you'd put your hands on it and it would warm you. That's one issue. The other issue is the smoke. This is hazardous for health. It's particulate matter. This stuff gets in your lungs. I mean, it's interesting, like we evolved, right, from cave dwelling people. And, through evolution, probably we developed sort of adaptations in our respiratory system for that because we burned stuff in our grottos, in our caves. So it probably wasn't that great, living in a cave with like all this smoke and stuff like that. So we can do better. We can do better. So, what is the function of this thing? I mean, one, it's like nice to look at, nice to look at. There's something about looking at a fire that's like the little bits of hot stuff are like swirling. There's a nice shape to it, a nice form to it. And then the other, function is to heat, and that's for our bodies and for our food. In this case, our food is this little marshmallow right here, right? Marshmallows are nice. They're sugars, they're hydrocarbons also. So that's the function, I guess, of this fire. And I was just riffing a little bit on the idea of using iron as a fuel to decarbonize the Christmas market. So I'll show you that now. Is that what's next here? Let's see, we're a bit disorganized, but that's okay. We're going to go down here. We're going to talk about these two innovations, Altiro. Let's start with Altiro. So Altiro Energy, this is a startup that came out of McGill Labs, the Alternative Fuel Laboratories. Hashtag disclaimer, I worked with this group in professional capacities on research projects, and I shared on that last week's episode about the aluminum fuel. And all opinions are my own on this episode. So that's the disclaimer done. So Altiro Energy, here's a flame. Isn't it lovely to look at? This thing is an iron flame. Iron comes in, mixes with air, and burns. Yes, it burns. Look at that beautiful, those sparkles. This is a sparkler, really. I mean, and they're working on the design of this thing. This looks nice, but it's maybe too long. It needs to be compact. It needs to have turbulent stability. And so what we could do here, and I need to just do one thing here. No, it's locked. Okay, good. Oh my God, we didn't want to do that. Let's erase this and this. So the idea here is that if we want to decarbonize Christmas, we can put this inside of a glass tube, quartz or something like this, right? So we can contain it. And then the idea that I've also shared in previous episodes is that iron, well, maybe you can't see that right now. We're going to move it over a little bit out of my way. There we go. Iron plus air comes in here. The iron gets burned, and what comes out here is iron oxides, rust, really, rust. The rusting of that iron powder, the conversion of the iron powder into iron oxide powder releases heat. So this thing is a radiant heater. This thing is providing heat. Heat. This is heat. And it's also beautiful to look at. It's red. You can feel the glow. You can feel the heat on your face. And there's no smoke. No smoke. Hallelujah. No smoke. And what you could also do is have up here, again, like some tubes, you would have a heat exchanger also, heat exchanger, which would provide the heat for your bum, for your hands, for those tubes, the metal tubes that go around the fire. They could also be heated, and you could have a lovely carbon-free, particulate matter-free, fully decarbonized Christmas market heating solution based on iron fuel. And parentheses, right? the iron, you need to put in energy here. So that become by either hydrogen or electricity or some combination of things. The iron oxides need to get re-energized, recharged and re-energized back into iron in this infinite loop here. This is a loop, circular energy, circular fuel based on iron. So I really believe that iron could decarbonize Christmas by replacing open air, wood fired, nasty, dirty, smoky, stinky fires that are also inefficient for cooking. We could replace those by lovely, high tech, rocket fueled, iron, metal, clean metal burning, circular, carbon free, fully contained, zero emission heat solution that would be beautiful and wonderful to look at also. So this solution is also interesting for this use case here that I was sharing. So let's dive into this one now. This diesel fuel burners here. So there's down here, this is diesel. There's a diesel tank there. There's a pump here. It pumps the diesel. It sprays the diesel. It gets burned in here. Then in here, there's a heat exchanger. Air comes in, and then hot air comes out here. And right, the particulate matter, the NOx, all the emissions, the carbon dioxide, the burned products comes out here, products of combustion. I mean, the reason that this, right, I mean, it's super convenient, right? Liquid hydrocarbon fuels are absolutely super convenient. They can be transported like this in these tanks, right? You can carry them by hand in jugs. I mean, you could have someone come, once a day and just fill this up with diesel fuel. And I believe that the same thing is true for these metal powders, these iron powders, that they can be carried in jugs. It's non-toxic. Also, it won't spill. It won't leak. If it spills, you just get a shovel and pick it back up with a broom and a shovel and put it back in your jug. And that we could be converting this into iron-powered remote heat solutions for temporary heat solutions. So I wanted to, well, I was thinking maybe, well, I went into the details, okay? I went to the website of this power rental company. They offer lots of solutions. And this equipment is from Flagro. There's a few different models here, and you can see all of the specs, right? So this thing carries 42 US gallons, 14 hours worth of capacity of operation at full power, I guess, providing 390,000 BTUs probably per hour, I guess, BTUs per hour. So I'm not going to do a unit conversion in front of you now on the whiteboard. That's not really what we're up to here at the Energy Sketch, although maybe I should apologize because I wish that I had the units worked out. But let's just sketch kind of what that might look like, right? So there's a capacity here, 42 US gallons. You'd want to multiply that by essentially the lower heating value of the diesel, which would be in the units of, if we're in metric units, this would be like megajoules per liter, or megawatt hours per meter cubed, or anything like this. An energy, it's an energy per unit volume. This is a energy density quote, energy density, right? So you'd multiply that by that, and this would give you some amount of energy that you can store in this thing here. And typically, and I've shown this graph in the past, you would have energy per unit volume here, and you'd have energy per unit mass here. And diesel sits somewhere here on the graph, and I believe iron sits like somewhere around there. So like they're roughly the same on an energy per volume basis, although there is some details about the morphology, the form of that iron, if it's in powder or pellets, or does it need to be ground down. But these are essentially like, on the same order of magnitude, although it does mean that the iron is going to be a bit heavier to carry But generally in these applications, maybe weight is not such an issue. It's more the volume that's an issue. So, but there is the the other side is that this does get converted into iron oxides, which do take up more space. So there's a logistics question there to be answered, but I don't think that's necessarily a big issue. So we could work out all the numbers of like, what's the size of this container here, really, and what would be the equivalent. What would be the equivalent size of a iron sort of a small little silo? This is the idea of these power rental companies. The new business model would be that you would install this silo. You would install. Let's. Where are we going here? We're going to sketch that here, right? Instead of this diesel tank, get rid of the diesel tank. Install a small silo that's piled up with pellets of iron, and there's another silo over here where the oxides go in the other silo, and this feeds in here, makes the heat, and feeds out here. And once in a while, once a day, once every couple days, your folks, they come and they haul away the oxides to take back to home base, to headquarters, to be recharged, and they fill up the iron oxide. So a beautiful emissions free, decarbonized, clean, no soot, no NOx, no particulate matter, just clean burning heat from iron. Isn't that lovely? Now, there's one more innovation that we want to talk about, which is in the same space, but slightly different. FEX Energy. And you can see here what their technology is, iron arc reactor. So it's a bit different. Use case is a bit different. Essentially, what they do, if I understand correctly, is they have a sort of a technology that is charged up by electricity. So you charge this thing with electricity. And inside, there's various equipment, including the heart of this thing, which is their invention, is the iron arc reactor. Let's just draw it as a tube, maybe. And electricity comes in, and also air comes in, air at T ambient. And they charge it when, let's say, at night or when electricity is cheap, etc. Pardon me, my phone is ringing. We'll turn that off. Charge it up when electricity prices are low or when demand is low. And then when electricity prices are high, but you still need the heat, you turn it on. And when it's turned on, then air comes out at 900 degrees C. So this is the other technology, and they don't have much details on their technology right now. I know they're working furiously in the lab developing this thing, and super excited to see some news on that whenever that's available. But this could equally decarbonize this thing, right? Instead of these mobile diesel burners, you would install this mobile unit here, this sort of shipping container size thing, and maybe it could be connected to the grid, charge it at night, discharge the heat during the day. This thing is super interesting and nice technology development happening at McGill with iron fuel. So I think we're all ranted out today, folks. What did we talk about? We talked about buildings and the annoying part where when you're in the buffer zone in between two doors, it's cold outside, it's hot inside. This should be a buffer zone. Please don't put radiant heaters blowing heat that's just going to be wasted and go straight to the outside. Focus more on passive heating and nice design. Keep this as a buffer zone between the hot and the cold, and let it get to a sort of mid temperature. And of course, you may need to heat it for services, for water pipes, all these things, but this can be managed in a way that doesn't just waste that beautiful heat that we pay dearly for going straight out to the atmosphere. And then we ranted a little bit about open air fires and Christmas markets and how there's a lot of downsides to this thing. I mean, we're breathing in the smoke, it's getting in our clothes. We need to put these rounds and rounds of metal that are cold to the touch. I was so excited when I happened upon this thing. I thought, oh, how brilliant. It's got heat. It's got hand warming. But no, it was just for safety protection. We can do better. We can and we must do better than open air fires for heat and cooking. And one way to do that is with iron flames, this beautiful sparkler here of iron burning. We can put this in a glass tube, get radiant heat from it, feel the heat on our face, on our hands, and also appreciate the beauty of that flow, of that turbulence. And also at the same time, capture heat for other purposes, for heating of our bodies, our hands, our spaces. And we can use that technology to decarbonize other challenging areas like construction sites where we need to bring in these temporary diesel powered heaters. We can also have temporary iron burning heaters or iron arc reactor technology from FEX Energy. So thanks so much for tuning in, folks. It's been fun ranting a little bit about decarbonized heat today, and wishing you all a lovely warm day. There's a snowstorm here yesterday. It's beautifully sunny today, but the teams of snow clearing are out and about in full force here, keeping the city moving, the city running. So be well, folks. See you later. Thanks so much for tuning in to the Energy Sketch. Toodaloo.